In this video, I'm going to be introducing you to the cumulative distribution function. The cumulative distribution function is derived from a probability density function, and it is a function that tells us the probability under a PDF up to a certain point. So just for example, if we have a PDF that looks like, let's say, this. So it's valid between those 2 points, let's say that's 1 and 3, and 0 otherwise. Just for argument's sake, let's just pretend that that's minus x squared. It's not, of course, but let's just say that it is. So between 1 and 3 and 0 otherwise. So the cumulative distribution function will tell us the value of the area up to any point. So if I wanted to know the area up to, say, 2.5, it would tell me that area. And so as you go along your x-axis, the probability will always increase. So it's got a cumulative look to it. So if there's 0, 1, 2, 3, 4 probabilities, tops out at 1. So it's going to be nothing until it hits 1. Then it's going to start increasing in a cumulative fashion till it hits 3, where it becomes 1, and then it's tops out at 1. So after 3, it's still 1. And that's why we have a different notation for it as well. So the cumulative distribution function is capital Fx. And if we're going from our function here, where x is between 1 and 0, we're going to say that it's 0 when x is less than 1. So we can see that that's this bit here. When x is less than 1, the probability is at 0. Then between 1 and 3, so between these 2 points here, it's going to be defined by a particular function. So let's say it's fx between 1 and 3, and then it's 1 when x is greater than 3. So we can see at this point here, when it becomes this point here, when it hits 3, it's topped out at 1. So that's one of the major differences between cumulative distribution functions and PDFs. We can see that PDF has a function and then it's 0 otherwise. That's shown by these lines here that touch the x-axis. And for a cumulative distribution function, it's 0 below its lowest limit and it's 1 above its biggest limit. The last thing I want to mention in this video is that we can go between a PDF and a CDF, our cumulative distribution function, in different ways. So to get from our PDF to our CDF, we need to integrate, and to go from our cumulative distribution function back to our probability density function, we need to differentiate. And in some future videos I'm going to be showing you how firstly we'll integrate to get from a PDF to CDF, and then in a later video after that I'll be showing you how to get from a CDF back to a PDF by differentiation. So just writing it generally, if we have a PDF, that is the same as integrating the CDF, and if we have a CDF, cumulative distribution function, that's the same as integrating our PDF between the lowest limit and the top sorry, the top limit, not the top limit, but x. So we integrate between the lowest limit and x, and we'll be looking at how that works and how to do that in our next video.